All right, so welcome to this channel. Today I'm going to do a very popular computer science problem, which is to reverse a linked list. Now, when I first saw this problem, I thought it was really difficult, but now that I will understand the concept, I realize it's very basic, but at the same time it can be difficult if you need to wrap your head around the concept. So just quickly to go over what that looks like in terms of the problem. So a linked list really is, I'll just show what that looks like here. Let's say we have a node. This thing will work. Okay, yep. We have a node pointing to another node, pointing to another node, pointing to another node, pointing to another node. So to reverse this linked list, what the output will look is, output will look like this: 5 pointing to the 4, pointing to the 3, pointing to the 2, which eventually points to the 1. Now this is what you call a singly linked list, which means that a node has a pointer to the next node. Now a doubly linked list will mean that something like this, which means this node points to this node and it goes back like this. So in our case, what we're working with is a singly linked list. So that simply means that we do not have these arrows that point back to the other node. So how do we do this? How do we take this one on top, which is our inputs, and reverse the linked list? So how this will work is, the solution is kind of simple, but at the same time, like I said, it might be kind of hard to wrap your head around. So let me just erase all this real quick. So what does the solution look like? So what we need to do is take this pointer, which is pointing to this 2, and we want it to point it back to, let me just get this, point it back to the 1. We want the 3 to point back to the 2. We want the 4 to point back to the 3. So we have to have a way of tracking this, we need to have a way of tracking this particular node, every single node. And how do we do this? So it will require us to have a pointer here. Let's call this pointer number 2. And then what we'll also require is to have another pointer number 3. So at every point in time, as we iterate through this linked list, we want to know what was the next node in the linked list. So conceptually, we will move this P2 and we'll move this here. And then we will want to take this arrow, which is this, and then we want to point this backwards this way. So the solution is pretty basic. What we'll need to do is we need to introduce one more pointer, and I'll explain why. Let's call this P1. Okay? Now leave this back here like this. So we want to iterate through the entire list, and as well iteration through the list, we want to take the pointer and let it point to the previous node. Now, like I said, it was a doubly linked list. We can always know what the previous node is, but how do we track the previous node in this case when all we just have is a .next? So I'll just show you what a node looks like on a very high level. We have a node, and this is in Python. If we initialize this, what that means is we have a self and we have a value. Self dot value will be equal to value, and we always have a way of tracking our .next pointer, which in this case, when you initialize it, is none. But we don't have a previous pointer. We don't have any way of referencing the previous node, so how do we track this? So what that will look like is, here's what the solution is. Let's just get straight to the solution. The solution will be, and here's what our solution will be. So what we will do is, while P2, which is this pointer, has a value, which means is not none, we want to say P3 will be p2.next, let me write this properly, p2.next, and then, so p3 every time will be the next node after p2. Then this pointer will have to point back to what it was to the previous pointer. So this pointer is represented by p2.next is equals to p1. Then once we do that, we will make p1 equal to p2 and p2 equals to p3. Now conceptually at the high level it's kind of tricky to understand this, but I'm going to walk you through and you see what this means in a second. So to do that, let's just erase this, right? And then let's say we call this p1 here. So we have p2 and p3. So p1 is just really the head, or not really the head, it's just an empty pointer. The head is p2. It's just an empty pointer pointing to nothing pretty much. So following this pattern, what we're going to do is we will say that p3, which is defined, is p2.next. So we now say p2.next is equals to p1. What that means is we will erase this, p2.next, and then we'll point this to p1, which is this arrow is pointing here, right? So p1 is equals to p3. We take our p1, which is this. We take our p1, or p1 is equals to p2, excuse me. We put p1 here, and p2 is equals to p3. What that means is p2 now becomes right here. P2 and p3 are the same, right? So is p2 none? No. So we say p3 is equals to p2.next. So this is our p3. Our p3 in this case is now equals to p2.next. This is p3, which is p2.next. Then p2.next, which is this arrow, is now equal to p1. So what that means is, we take this away, p2.next is equals to p1. p2.next is equals to p1. p1 is equals to p2. So we take p1 here, and we move it to p2. And p2, we move it to p3. That's p2. So is p2 none? No, it's not none. So p3 is equals to p2.next once again. So p3 is equals to p2.next. So this will be that p3. p2.next is equals to p1, referencing the arrow. So we'll take this arrow. This arrow is equals to p1. That's this. p1 is equals to p2. So this is our p1. We move our p1 and we put it here. And p2 is equals to p3. So p2 once again moves away from here, and p2 is equals to 3, 3. Here we have p2. So we check. Aha. Is p2 not? It's not. So p3 is equals to p2.next. So we remove p3. It becomes p2.next. This is our p3. p3.next, p2.next is equals to p1, which is this arrow. p2.next is equals to p1, right? p1 is equals to p2. So p1 comes here. p1 comes here. Remember, p2 is still here. p1 is equals to p2. And then p2 is equals to p3. So remove p2 equals to p3. Right? We check, is p2 none? It's still not none. So p3 is equals to p2.next. So at this point we have gotten to the end. So p3 points to nothing, to null. So p3 points to nothing. Right? So p3 is gone. It's pointing to null. p2.next is equals to p1, which is p2.next, which is the arrow, is now pointing to p1. Right? p2 is pointing to p1. p1 is equals to p2. So we move p1 from here, and p1 becomes p2, right? And p2 is equals to p3. So p2 once again is pointing to nothing. And so we check, is p2 is not none? p2 is not none. So at this point we have reversed the linked list, as you can see, but if we continue, obviously P2 now becomes none, but at the same time this works because we've gotten to the end of the linked list, right? So that's the conceptual solution. So if we look at it very well, our output, like we've seen, is 1. So we have reversed the linked list. And as you can see, this is what our output was supposed to be, which is what we have here, which is correct. So it's just wrapping your head around the concept. If you can draw it out like this, then it makes sense. So let's see what it looks like in code. Reverse the linked list. Like I said, let's define our node, which takes in the self, takes in the value. It should be self. This is just not necessary, but it's just good to have an idea what that looks like. Sorry, this is wrong. Sorry, class node. You initialize the linked list, which now takes in self and value. Sweet. Next, what do we say? We say self.value is equals to value, and self dot next in this case is equals to none, right? I have an extension that tries to figure out what I'm trying to type, so that's why you see that. Anyways, so now let's define this. So we define reverse, well, I can't spell, reverse linked list. Don't mind the autocomplete. Like I said, I have a which passes in the head, which is a kind of node, but it's the head of the linked list. So like I said, the linked list looks something like this: 1 pointing to 2, which points to 3. Excuse me, which points to 3, which points. Okay, here we are: 4, 5, 6, 7, 8, 9. So we have the head of the linked list. This does do this. So what do we do? Following our earlier pattern. So let's just write this out in a way that looks good. Excuse me. So we have some things that we're tracking. We're tracking P1, we're tracking P2, and of course we're tracking P3. And like we said, P1 will be the P1 will be your previous node. P2 we'll call this our current node, and P3 we call this our next node. Yeah. All right, so what do we do? As mentioned, we have a while loop. First of all, we have to define our values. So we say previous node, we have previous node is equal, and of course our current node. Now our previous node obviously is none, and our current node will be the head of the linked list. Okay. Previous node, current node. What's wrong with this? Yeah, we passed the head. This is fine. And so. Okay. What's wrong with this? Anyways, I'll look at that. So what are we trying to do? We said that while current node, let's not worry about syntax too much. While current node is not none, we are saying our next node, which is P3, like the example we gave, our next node is equals to current node dot next. Then our pointer, which is our current node dot next. Current node our pointer. I can type current node dot next. Current node dot next will point to our previous node. Yep. Then P1 points to P2, so previous node moves to current node. And in our current node, moves to next node. And when the loop has ended, our current node will eventually go out of bounds, and what we'll have left at the end of the linked list will be our previous node. Yep. So this is what this is. It should be a return. I don't know why my syntax is crap, but this looks good. And yeah, so previous node, current node, node, none. There's always something I'm doing wrong. Head is not defined. This is our head. So we have previous node. Let's change the case to load, which doesn't really matter. But previous node, current node is equal to none. So your previous node is none. Your current node is not header, but it's head. Well, current node is not none. Next node is current node.next. Current node.next is equal to previous node. Previous node is equal to current node, and current node is equal to next node. And then you return your previous node. So this looks good. I'm not sure why the syntax is off, but conceptually this looks fine. So previous node, current node, and then you iterate through the linked list. When it gets to the end of the linked list, when your current node is none, then it comes out of this while loop. It says your next node will be your current node.next. Your current node.next, which is the pointer, points back to the previous node. Then your previous node moves to your current node, and your current node moves to your next node. And then you return previous node, because at this time, current node will have broken out of the out list. So this is it. This is my interesting attempt at solving the how to reverse a linked list. And yeah, so hopefully we'll do more of these for fun. Till next time, my wish for you is that you learn how to code, because coding is changing and will change the world. For those who get involved early, in my personal opinion, will greatly impact the future. And if that is you, then let's go change the world.
If you would like to create more awareness for your brand or content, or you would like to earn additional income, register now on www.Kleekee.com. The more you share, the more you earn. Kleekee.